Hey 8th graders, so as you guys already know, we're already getting close to nearing the end of our gravity unit. Earlier this week you should have added a section to your OneNote for gravity, and you guys should have added 2 pages, mass and weight, which we've already talked about and added to our notebook. And today you're going to add gravity. So if you haven't already, go into Teams, copy and paste this picture and add it into your OneNote. Okay, so obviously our topic for today is going to be gravity and gravitational force. So gravity is a force, you guys should know this by now, we've gone through it quite a bit this week, that attracts an object to another object with mass. So if an object has mass at all, it has gravity. So you have gravity. Because comparatively you're not the size of a planet, you don't have very much gravity, but you do have gravity because you have a mass. Okay, your pencil, okay, it has gravity as well. Not a lot, not even enough to stop me from dropping it and having that pencil fall to the floor. Why? Well, because the Earth also has gravity. It is significantly larger than me or my pencil. Okay, so I have gravity, my pencil has gravity, but the Earth, because it is so much larger than me and my pencil, has more gravity. That way, when I let go of my pencil, it falls to the ground. It doesn't have enough of a gravitational force, nor do I have enough of a gravitational force to prevent my pencil from falling to the ground. Okay, so gravity depends on 2 factors, like I just said, mass of an object. Okay, Earth has more gravity than, say, I do or my pencil does because it has more mass. So any object with mass has gravity, so as our mass of that object increases, so does the gravity. As the mass decreases, so does the gravity. So you guys saw this the other day when we did your weight on other worlds. Okay, you saw that because your weight depends on gravity, that if you go somewhere like Jupiter, where the planet is huge and has a really large mass, okay, you have a larger gravity there and therefore a larger weight. Okay, but if you go to somewhere like Mercury, which is considerably smaller than Jupiter, you notice that because it has less of a mass for the planet, we have less gravity, and therefore, again, we have a lower weight. Okay? The other one that you guys will see affects gravity is distance. So every object that has a mass has a gravity, but if those 2 objects are further apart, they're less likely to feel the force. Okay, so the closer they get, the more they see the force. So when you guys did the gravity in orbits the other day, you guys saw that if you guys changed the mass of an object or changed the distance between the objects, you also changed the amount of gravity. So they had a hard time kind of sticking together and orbiting. Okay, so distance between objects is going to affect gravity. So the larger the distance between 2 objects, the less that they're going to feel that gravitational force. The closer the distance or the smaller the distance, the more they're going to feel that gravitational force. So you guys can even see a difference in gravitational force if you guys go to the top of Mount Everest. Okay, you're further from the center of the Earth than when you guys are at sea level. You can even have a slight difference in gravity there. Obviously, if you leave Earth's atmosphere, you still feel its gravity. The moon still feels its gravity. That's why it orbits around us. But if we were to move the moon further away, it might not feel its gravity as much, and it won't necessarily stay in that orbit depending on how far we move the moon away. Okay, so those are your little notes that you guys added for today. Your activity today is part 1 of the pHet gravitational force activity. So I'm going to go ahead and just pull those up. I split my screen for you guys today. So on one side you guys will see the link you're using, and on the other side you'll see the worksheet. So this should be an assignments for you guys. Okay, obviously this is the link that you were using. Okay, and I'll go back and forth between blowing it up and shrinking it. Today you're just doing part 1. Tomorrow you'll have a separate video that I go through, even a separate part of your worksheet that I go through. So the Excel document that's attached to this, that will be for part 2. So you don't need to worry about the Excel sheet that's on there today. Tomorrow you guys will have to do something with the Excel sheet. All right, so let's just take a look at part 1. We know that all objects have gravity, but the amount of gravity depends on the sizes of the respective objects. In this experiment, you will be examining the amount of gravity between 2 objects. So when you open this up, you see that this blue object has a mass of 100 kilograms. And you see that this red object has a mass of 400 kilograms. So each of those objects has gravity. But which one has the higher gravity? The blue object or the red object, and why? Okay, so you should have said the red object because it has a higher mass. But what you notice is up here, this tells you the amount of force. If the red object has a larger mass and therefore a larger gravity, why are these 2 numbers the same? Why is the force of this red object on the blue object the same as the force on the blue object to the red object? Who can tell me what we've learned about so far this year and past units that explain why these numbers are the same? Okay. You guys remember us looking at Newton's third law. Newton's third law that says when one object exerts a force on another object, that object exerts a force equal but in an opposite direction back on the first object. So because of Newton's third law, this number is going to be the same. Okay, this force of the red on the blue is going to be the same as the blue on the red. Okay, it's the larger of the two numbers because of Newton's third law. Okay, notice that the arrows are opposite. Notice that I can also make the arrows bigger by moving them closer. So that kind of demonstrates what distance does to gravity. Okay, if I move them further apart, notice how small the arrows are. I can also change the mass of objects. Now my blue object is larger, okay, but our force is still the same. So regardless of mass, okay, our force is still going to be the same, but in an opposite direction, okay? So let's take a look at question 1. What is the size of the force on the red object? So if I go ahead and reset this back to my original. Okay, what is the size of the force of the red object on the blue object? So let me take a look at this really quick. You guys have a couple different options you can do. So probably the easiest for everyone is to just type in this number, 0.00000166852. But if any of you guys are really good at math and you're familiar with scientific notation, you guys can click this option right here, scientific notation, and you guys can write your number in scientific notation as well if that's easier. So 1.67, for those of you who are familiar with scientific notation, you cannot forget the times 10 to the negative 7. That is really important. Basically what that means is you're moving the decimal to the left 7 places, so it should be a really small number. So either one of those works. If you guys know scientific notation, you can write your answers like that. Or if you're just cool with the decimals, you guys can write your answer like that. Remember, this is a force. Gravity is a force. So we're going to use newtons as our label. Okay? So there's 2 options there. All right. So for that then, what is the size of the force of the red object on the blue object? Your answer is right here, 0.00000166852. Okay, notice that that's also the same for the red object on the blue. So you would copy and paste that answer or retype it. Okay, increase the size of the blue object till it equals the red. So you guys would take, all right, I need to make my blue object 400. Oh, there we go. And then you guys can fine tune with the arrows. And now rewrite your force. What are the force on each of those objects? So this is pretty simple. You guys are just basically following instructions. Decrease the size of the red object until it is half the mass. Okay, so if we have 400 on blue, we would need to take this down to 200. Oops. I got it. Okay, and then what general rule can you write to explain the forces between objects of different masses? So basically, if you change the mass, if you increase or decrease the mass of your object, what does that do to your gravitational force? Does it increase or decrease it? Okay, if the moon were twice as massive as it is, right now it's about 1/6 the size of Earth, how would that change the gravitational pull on the Earth? So talk about that force between Earth and the moon if we increase the size of the moon by 2. Okay, change the blue object's mass to 50, so you guys would take this down to 50, and the red object's mass to 30. And now you guys are going to mess with distance. So you're going to be moving one side closer than the other. Okay, how did the force on the blue object change? How did the force on the red object change? So answer those 2 questions. And then predict what would happen if either humanoid, so these dudes are the humanoids, move further away from the other object. Test it. Okay? So just move one guy and see what happens. All right. For part 2, you guys are going to come back to a different video, and you're going to be using the Excel sheet for that. Hope you all are having a wonderful day, and I will talk to you soon. Bye.